Hi ladies, in this video we're going to go through the theory for 8F, which is using tree diagrams. So a tree diagram is a way that you can look at different probabilities that involve two or more stages. So kind of like flipping a coin twice or rolling a dice twice or even three times, selecting groups of people, stuff like that. So these three dots in the key ideas are extremely important to remember. So branch probabilities are used to describe the chance of each outcome at each step. Each outcome for the experiment is obtained by multiplying the branch probabilities. So we'll have a look at this in a sec. And branch probabilities will depend on whether selection is made with or without replacement. So with replacement is different to without replacement. All right, so let's have a look first at question 1. See if I can make it a little bit smaller so we can see the whole thing. All right, boxes A and B contain 4 counters each. Box A contains 1 yellow and 3 orange counters, and box B contains 3 yellow and 1 orange counter. A box is chosen at random and then a single counter is selected. Okay, so if box A is chosen, what is the probability of selecting a yellow counter? So if we just look at box A, I might just write this over here. Oh, that's a bit thick. Sorry, didn't expect that to happen. Okay, let's start again. So box A, we have 1 yellow and hopefully my orange doesn't look too much like the yellow, and 3 orange. Okay, so for question A, if box A is chosen, what is the probability of selecting a yellow counter? So we've got a 1 in 4 chance of getting a yellow counter. Now, if box B is chosen, and in box B we have, let me just see, 3 yellow and 1 orange. There we go. What's the probability of getting a yellow? It's 3 out of 4. Now, question C, we've got to represent it on a tree diagram, and they've kind of already drawn the tree diagram for us, which is great. Now, first of all, we've got to pick a box, and then we pick a counter. So the box, we can do A or B. So we have a 50-50 chance or a half chance for each. Now, along your branches at each step, it always adds up to 1. Okay, so even if I didn't know what was going on, I would know that is a half. Okay, because a half plus a half gives you 1. All right, and then we're selecting the counter. So the counter can be yellow or orange. So if we're box A, the probability of getting yellow is 1/4, which is already written for you. And box A and then an orange is 3 over 4. So remember, they have to add up to 1. But you can also see over here that we've got 3 orange counters. So your outcome, you just write along the branches. So we've got A yellow, and then the next one is A orange. And your probability, we just multiply along the branches. So it's 1/2 times 3/4. When you're multiplying fractions, you multiply the numerator. So 1 times 3 gives you 3, 2 times 4 gives you 8, and always simplify if you can, but we can't for this one. Okay, then going on to box B. So the probability of getting a yellow from box B is 3 over 4. And need to fill in the orange here. So the probability of getting an orange is 1 over 4. So your outcomes now are B yellow and B orange. Okay, so they're your different possibilities. And to get your probabilities, you add along your, you multiply along your branches. So 1/2 times 3/4, which is 3 over 8. And then 1/4 times 1/2. Or I did set it around the other way, is 1 over 8. And when you add up all these probabilities along here, it should equal 1. Okay, so all your outcomes should add up to 1. the probability of all your outcomes. What is the probability of selecting a box B and a yellow counter? So we go B yellow, that's 3/8. What is the probability of selecting a yellow counter? So you've got to look at all the ones that you've got a yellow. So we can do A yellow, which is 1/8. And we can also do B yellow, which is 3/8. So when you've got multiple possible outcomes, you add them. So you multiply along your branches, but if we're looking at adding up different outcomes, you just add their probabilities together. So 1/8 plus 3/8 is 4/8, and always simplify that. So that's a half. What was I going to say? With fractions, or with probability, always leave them in fractions, and always, only simplify it at the end, because you can see here that to add them, we need the same denominator. So it's always a good idea to keep the denominators the same until you get to your answer, and then simplifying it then. All right, I need a bit more space for this question. So I'm just going to, let's just insert a new page for question 4. And I'll insert a page here. I've got a bit of space to do our working out. Okay, question 4. 2 students are selected from a group of 3 males and 4 females without replacement. Draw a tree diagram. Okay, so we'll draw a tree diagram first. We've got without replacement, so that means, if I choose one person who's Mary, I can't choose Mary again. They've got to be 2 different people. So this is our first student, and you can have a male or a female. Now, first of all, we've started with 3 males, so it's 3 out of a possible 7 people. So there's 7 people, so 3 out of 7, and then 4 females, so 4/7. So remember, they have to add up to 1. So 3/7 and 4/7 is equal to 1. So good, I haven't made any mistakes. And then we've got to choose the second person. So your second person here can be male or female, male or female. Now, because it's without replacement, so you got to choose 2 different people. So obviously, if you're choosing 2 people, you can't clone that person and have the same person. So since we've already selected a male, the number of males has gone down from 3 to 2. And the number of people have gone from 7 to 6. So when you think about it, I might just write it here. We had 3 males and 4 females. Our first selection, we chose a male, so that male's gone. He's standing up here out the front of the classroom. And we're left with 6 people, and 2 of them are males and 4 of them are females. Okay, so sometimes it's helped to draw, don't actually need to draw the males and the females, but just using the letter might help you understand. Go away. All right, now for the next one, so that was if we chose a male first, but what if we chose a female first? I'm going to put that male back, he's gone back to the group of students. This time we chose a female. So there she goes, she's now at the front of the class. So we're left with 6 students again, so it's out of 6. How many males are there? There's 3. And how many females? There's also 3. Now, I'm just going to leave them as unsimplified fractions. So 2/6, you saw I didn't change that to 1/3. And that's because if I'm doing fractions later, it's sometimes a little bit easier to keep them just like that and only simplify for your final answer. Okay, so now we've got them. We're only choosing 2 students, so I don't need to extend my tree diagram. The longer your tree diagram, or the bigger your tree diagram, the messier it gets. They get very messy very quickly. Okay, so the possibilities is you just read along your branches. So we've got male, 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 female, female, male, female, female. Okay, so you've got 4 different combinations you can have. Your probabilities, we just go along the branches. So 3/7 times 2/6 Now, when you're multiplying fractions, you just multiply your numerators. So 3 times 2 is 6. 7 times 6 is 42. And then you can just simplify that. So that's going to simplify to, I'm just making sure I'm doing this correctly, 1/7. Yeah, sorry, I just had a bit of a lapse in concentration. Okay. Sometimes I think it would be easier to simplify these fractions. 3 times 4 gives you 12. 7 times 6 is 42. So again, simplifying, is that going to be 2/7? And then we've got 4/7 times 3/6. Okay, so it's going to be same as before. So 12/42, which is 2/7. And then female, we've got 4/7 times 3/6 gives you 12/42. Okay, I'm checking as I'm going. All right, so we've got 7/7, which is good. Okay, so I just added all these up. Remember, they have to equal 1, and they do. So the probability of getting 2 males, we've done, male, male, is 1/7. 1 male and 1 female, we can have male, female, or female, male. So we just add them together. So 2/7 plus 2/7 gives you 4/7. 2 females is 2/7. And 2 people, either both male or both female. So we can have male, male, which is 1/7, or we can have 2 females, so 2/7. So we add them together. So we have 3/7. This experiment is repeated with replacement. Find the answers to each question in part A. Oh, with replacement, okay. So I'm going to show you how to set up the tree diagram just very quickly. Okay, so we're doing our 2 students. All right, so the probability of getting a male, so we had 3 males out of 7 students and 4 females out of 7. This same person can be selected again. So we still have 3 males and 7 females. Sorry, 3 males out of 7 students, 4 females out of 7 students, 3/7, 4/7. So when you're doing without replacement, on your next step, they do reduce, but you need to know how they reduce. So it all depends on this step here. Okay, see if you can do that, because it's pretty much now the same. Okay, your outcomes are the same, but your probabilities do change because we've changed this second step because we're doing with replacement. Okay, let's have a look at question 7. I'll just get a bit of space here. All right, cans of sliced peaches produced by Just Peaches are sometimes underweight. A box of 10 cans, so I'm just going to underline some important information, selected from the factory, and then 2 cans from the 10 are tested without replacement. Without replacement. This particular box of 10 cans is known to have 2 cans that are underweight. Okay, so let me just read the question again. Cans of sliced peaches are sometimes underweight. A box of 10 cans is selected from the factory, and then 2 cans from the 10 are tested without replacement. So we'll do the first can and the second can. So we're selecting 2, and we're doing it without replacement. So when we do our probabilities, we've got to take that into consideration. This particular box of 10 cans is known to have 2 cans that are underweight. Okay, so we're going to have, I guess, normal and underweight. So in my first one, normal and underweight. The probability for underweight is 2 out of 10 cans, and normal will then mean it's 8 out of 10. Okay, so we had 2 that were underweight and 8 normal, and that's what it said in the question. Then our second selection, we can have either a normal can or an underweight. and a normal can or an underweight. Now, because it's without replacement, so we're looking at 2 separate cans, in our second selection, it does reduce to 9, and we've already selected 1 normal one, so that goes down to 7. Again, it's out of 9. We didn't select an underweight, so that stays as 2/9. Then we look at getting an underweight can first. So again, does reduce to 9, but our normal stays at 8. Okay, so we still have all 8 there, but our underweight reduces to 1. Okay, so we already took an underweight, so we've only left with 1 underweight can left. So just check your branches do add up to 1, and they do. So you can list your outcomes. Okay, so we're going to have NN. They've written not underweight, so if you want to read the N as a not underweight, you can, and U as underweight. UN and UU. And I'm going to go ahead and do the probabilities. So remember, you read along your branches. So 8/10 times 7/9. 8 times 7 is 56/90. And I'm just going to leave it like that for now, just because I'm just going to answer the questions that need to be answered. 8/10 times 2/9, so that's 16/90. 2/10 times 8/9, so we've got 16/90, and then 2/10 times 1/9 leaves me with 2/90. So effectively, I should end up with 19/90 if I add all these together. Just 56, 66, 72, 82, 88, 90. Fabulous. Okay, so for question A, state the probability that the first can chosen will be underweight. Okay, so the first can, underweight is 2/10 or 1/5. Okay, so we're only looking at the first can, 1/5, and not underweight is 4/5. Use a tree diagram to find the probability. Both cans are underweight. So we go to UU, 2/90, which is 1/45. 1 can is underweight, so we're going to add these two together. So we're going to have 32/90. Might just do that here. Which is 16/45. And at least 1 can is underweight. So basically, we're going to do 1 minus 56/90, because sometimes it's easier to do 1 minus what you don't want than to work out what you do want. So that's going to be 44/90. No, it's not. It's going to be 34/90. Just change that. Which gives us 17/45. Okay, so that's at most 1 can is underweight. Oh, actually, what am I doing? Oh, no, I did it around the wrong way. I did at least 1 can is underweight. We want at most, so we can't have 2 cans underweight. So I took off the wrong amount. Let's just start that again. So we want 1 minus UU, so 1 minus 2/90. So 88/90, which gives you 44/45. All right, so question C, the factory passes the inspection of no cans are found to be underweight. Find the chance that this will occur and express your answer as a percentage rounded to 1 decimal place. The factory passes the inspection if no cans are found to be underweight. Okay, so we want NN, which is 56/90. And you can just do that on your calculator. I might just write that here. 56/90, which is, if you want to do that, So 28 over 45. And then you can just do that on your calculator as a percentage. All right, let's move on. Okay, next is more challenging questions, which I'll do in a separate video. Bye, girls.